All right, next we're going to look at how to write a function rule. So in other words, if you have maybe some x and y data, a pattern in numbers, how do we get a rule or an equation for that? And we'll start off with an introduction and a couple examples. So a couple tips I want to show you. First, you need to figure out if it's linear or nonlinear, okay? And for linear, there's a pretty straightforward rule you can always follow, where the rule will be equal to change times x plus start. And we'll get much more formal with this in our next unit, which is all about linear functions. But for now, it's just change times x plus start gives you the y value. And if you could find out what the change is and find out what the start is, you're good to go. For nonlinear, there's some guessing and checking you might need to do. You might want to look for some patterns also. You can also try to see if it's quadratic or exponential. For quadratic, you'll need to do 2 steps to get to the constant differences, and I'll show you that in an example what that means. But that is a very handy way to show that you have a quadratic. And for exponential, if you can look for consistent doubling or cutting in half or tripling, sort of a consistent multiplier, then you're probably dealing with an exponential function. So let's get started. We'll start with a linear function. And you don't always know that it's linear, but I'm giving it to you now that we are dealing with a linear function. And in part, I'm telling that because I wanted you to fill in some blanks here. What's the missing y value? Okay. I also always like to fill in the 0 also for x. Okay. So let's see what this pattern is. 3 down to 1 is a -2. -3 down to -5 is a -2. So this -2 is the change that we're looking for. So we already can tell, since we know it's linear, we already can tell that y is -2 times x plus something. And I said plus the start. What's the start mean? The start is also known as the y-intercept. And it's going to be that y value right there, the y value that corresponds to x being 0. So we can fill in some other numbers also. This looks like this is going to be a 5 to continue our -2 pattern. This is going to be a -1. Okay, so every time x goes up by 1, y drops by 2. And now we know our start. Our start is 5. So y equals -2x plus 5. You can always check this by plugging in a particular y value that you're interested in. So or an x value that you're interested in. Let's plug in x is 4. So let's see, is -3, which is our predicted y value, is that equal to -2 times our -4 plus 5? -3, is that equal to -8 plus 5? It is, it checks out. So it looks like we did the problem correctly. So this is our final equation there, our rule for this function. Let's look at a nonlinear example, and these are always a lot harder. And one place that you always want to start is just by looking at the differences. So -4 to -3 is up 1. -3 to 0 is up 3. 0 to 5 is up 5. So I hope you can tell that we don't have a linear function right here because these differences are changing. But let's take the differences of the differences and see what we get here. So this is +2, +2, +2, +2, and +2. Okay, so these are the first differences that would be consistent if we had linear, and these are the second differences, and since they are consistent, we know we have a quadratic function. And a quadratic function is going to look something like this. ax squared plus bx plus c. We might not have all of those pieces in the function we're dealing with today, but we definitely will have some sort of a squared piece to it. So now's the hard part. Now is where you need to do a little bit of guessing and checking, a little bit of looking for patterns, and just seeing if you can find a rule. I'm going to erase some of this to make things a little bit easier for us. But what we're really looking for now is a rule that takes a 0 and turns it into a -4. And it needs to be the same rule that turns a 1 into a -3, a 2 into 0, etc. So we're looking for one consistent rule that works for all those sort of conversions from the x's to the y's. So one place to start with this, if you don't see it right away, and I'm not seeing anything obvious right away, but one place to start is by, let's make an x squared column. I'll just sneak that in right there, and that might help us because we know there's going to be some sort of a squared component to our rule. 0 squared, 1 squared, 2 squared. So we're just counting up by our squares. 16, 25, and 36. Okay, so now let's take another look and now see if there's one consistent rule that can turn the 0 into a -4, 1 into a -3. I think I see it. I want to give you a chance to see if you see it. What's the consistent rule that can turn those x squared values into those y values? And it looks like all of our x squared values are 4 larger than the y values. Do you see that? So it looks to me like if we can take x squared and subtract 4, that gives us our y value. Okay, so let's test it. Let's test it, say, with x being 5 and y being 21. So we're going to test it with these values. So is 21 equal to 5 squared minus 4? It is. It checks out. Okay, so that's going to be our rule for this particular set of numbers, y equals x squared minus 4. And that's a good place to stop right there.